Namaste to everyone. So today we discuss a very simple topic, but the topic is very simple. If you try to answer by yourself, it's very hard to answer. That the question is something like this: why apple falls, why not moon? We know that one. I wrote apple here, any object, okay, from the inspiration of Mr. Newton. So I take apple here, okay. If we place apple, it will fall, right? If we place it, but we saw moon is always revolving around the earth. We learned from the elementary school, and also we saw the moon, right? But it doesn't fall. Why it's like that? This question is asked by some person, a young man who asked almost 400 years ago. His name is Mr. Newton. Because of that, lot of laws are came. You know that Newton's laws, gravitational, universal law of gravitational attraction, so and so. Because of that, industrial revolutions happened in the 18th century. Many things have happened like that. So try to answer this question. Every curious kid has this question, right? Why moon is sticking out there in the space, but everything fall into the space, everything fall into the earth. Why not moon fall into the earth and does not crash? So these many questions are there, but grown-ups are never ask these questions nowadays because they completely ignored. We try to answer this one using a very elementary idea that high school physics and high school mathematics, 11th grade mathematics. The thing is, if we have, I take an idea. Look here. If this is Earth, okay, I write this is Earth, and if you are here, okay, I take it as a moon. Okay, we know that when moon is revolving around the earth, okay, in a certain path, almost look like a circle. Okay, it's not a circle, okay, almost look like a circle. It's moving like this. It does not fall into the earth. But if we are here, okay, I placed you here, you definitely fall into the earth. You will get crash into the earth, definitely. Initially moving with the speed increases and finally crash into the earth. Fine. Why does not moon fall? It has a very simple concept. The concept is like this. You may heard about acceleration. Acceleration is final velocity minus initial velocity divided by time. Okay, delta t means how much time acceleration act. Okay, acceleration means, okay, if we are going like this, okay, you're going like this, I pushed you, okay, I pushed you like this. If you are going like this, so you are moving with a certain speed, it is represented by this vector. Okay, you're moving like this, I pushed you, now you're going like this. That means I pushed you means I changed your direction. Okay, I changed your path, I changed your velocity, speed, everything. Okay, that means I gave you an acceleration. That is acceleration. Acceleration is something which is responsible to change the velocity. Yeah, fine. Now how to calculate, how to find the acceleration, how to measure the direction of acceleration. Now look here, if you are moving in this direction, now you are moving like this. Okay, somehow you are moving like this after this time, after a certain instant of time, this time. Okay, if you did very quickly, that means I applied a greater acceleration. Don't worry about that one. Okay, please worry about this relation. That means how to find the acceleration direction. Place these two vectors together. Okay, v initial, same thing, same amount. This vector here, same direction, carry here. We call the end of the arrow called tail. So we place the tail here. So that means velocity was like this, now like this. It is changed from here to here. That means change it from here to here. This is change. V final minus V initial. Now, and the another concept in mathematics is A equal to B, LHS equal to RHS. That means in every sense these two are equal. If it is 5, this one is 5. If it is 10, this one is 10. And another thing is, this is a vector. It has another property. This is a vector. That means if it is in this direction, if this one is in this direction, B is also in the same direction. Okay, same length, that means same amount. Greater the length, greater the amount. Okay, so same, this is, if it is 5, this is 5, and these two are in the same direction. That's fine. So like that, LHS is equal to RHS. In the same way, we have an equation. Okay, vector A is equal to this. Okay, time is there. That means this one should be in the direction of This is what change is in which direction? This direction. Therefore this is the direction of acceleration also. Understood? This is the direction of acceleration also. I'll give an example, simple example. If you are going like this is your initial velocity, and someone pushed you, okay, someone pushed you, then you are going like this. It's here, right? Where you're going like this, someone pushed you, now you're going like this. So you're going like this, someone pushed you, now you're going like this, like that. So someone pushed you very greatly, okay, if you are going like this, someone pushed you very greatly, then you're going like this with a greater speed. Okay, fine. Now if you are not moving, you're at rest. Okay, your rest means your initial velocity is 0. That someone pushed you like this, then how you are going? Now you should go like this only, because that's the way, because you don't have an initial velocity. I'll prove that here. So if your initial velocity is 0, this part is 0, then acceleration in the direction of final velocity in the direction of acceleration only. Simple concept. Now I come back to this Earth and Moon and apple problem. This is Earth again. Moon is moving around the Earth with a certain speed. Okay, I don't know, Earth, someone threw the moon already. Moon got the velocity initially. How it got, we don't know. Someone threw the moon. So it is the velocity of the moon. Earth is always attracting the moon towards the center. It is attracting like this. Okay, attraction. I draw a little arrow because a little attraction is there at that distance. Now moon is going like this. Acceleration, final velocity. So now moon wants to go like this, but Earth once again attracts. So moon goes like this. Once again moon goes like this, wants to go like this, but Earth attracts, moon goes like this. Once again Earth attracts, moon goes like this. So if you trace this path, it gives a circular, almost circular path. I'm very bad in diagram, it's okay, drawing, but it almost gives a kind of a circular path. Every time moon trying to escape, Earth drags in. So every time moon tries to escape, Earth drags in, like that. But it cleverly does not fall. You may say that one, okay, if you are here, you don't have an initial velocity, you will straight fall into the Earth, right? If you have a certain initial velocity, I'll draw here, I'm sorry. So if you have an initial velocity, okay, this is you have an initial velocity. Is there any velocity is possible if I give a tiny push? If I give a very little push, okay, I'll mention in a little arrow. This is a big arrow. This is a little arrow means I push you very little. You have an initial velocity, less initial velocity. Got it? Earth attracts you. So now your velocity is something like this. If you want to go like this, Earth attracts you. Now your velocity is something like this. Finally, you crash into the Earth. That means any velocity not accepted, you need a greater velocity. This velocity, required velocity. Understood? Required velocity. So then only you trying to manage. Okay, it has this is called orbital speed. It requires certain speed. It has calculation. So in order to be sustained in the orbit, you need a certain speed only. Okay, if you have a greater speed, what will happen? Okay, this is Earth again. You have a greater speed. Earth will attract you. Now we are here. If you want to go here, go in this direction, Earth will attract you, you go here. So you try to go in certain orbit like this. Maybe you go like this, finally you are moving away, far away from the Earth, but you finally move away from the Earth. Later in time, your gravitational attraction on you keep on decreases, so less pushing. So you try to, every time you move away, less pushing, your direction completely changes, and finally you move away from the Earth. That's how you're moving from one planet to another planet. That's a way. It's a very simple way of understanding using high school physics. Thank you.